Okay, so now that we learned about the trig functions, the sine and the cosine, let's see if we can put the sine function to use. Now, I'd like to keep a running time. In other words, I'm going to add a variable. Now, here in the Blueprint editor, we have a My Blueprint tab. And we see under Graphs, we have Event Graph, and it's showing all of the events in the event graph that we have here. Begin play, actor begin overlap, which we haven't talked about yet, and event tick. Now beneath that we have functions. The construction script is one of the functions in the blueprint. We just inherit that. And beneath that we have variables. And we know that all actors have at least one component called the default scene root, and that is one of the variables. It's that scene component. But we can add more variables. We can either click the plus right here next to variables to add a new variable, or we could click add right here and choose variable. Now, I just added a new variable, and I'm going to call this t. Now, you see its data type right here next to the dropdown. Now, usually it'll be a Boolean by default. Mine shows float because I added a float variable earlier and deleted it while I was preparing for this lecture. And whatever you add, if you add another variable, that new variable will be the same type as the last variable you created. And you can, of course, delete variables here by selecting them and hitting delete. Now, this is an awful name for a variable. T is not very descriptive, but this is for demonstration purposes, and we're going to delete this very shortly once we're done testing it out. Now, your variable that you created is going to say bool by default, but we can open the dropdown and change its data type. Go ahead and change yours to float, and click on T and drag it out, and use get t. So we'll have the value of t here. And what I'd like to do is add to it every single frame. I'd like to add the value of delta seconds to it. So I'm going to drag off of delta seconds and use the plus sign to get an add node and add t to delta time. And we're going to use the result of this addition to set the value of t. Now, if we want, we can drag t out and release, and we can either get it or set it. I want a setter. We can also hold Control on the keyboard and click and drag out to get a getter. I'm going to delete that. And we can hold Alt to click and drag out to get a setter. So those are shortcuts. I'm going to delete that. Now let's set the value of t every frame to its old value plus delta time. So every single frame, we're adding delta time to this running time variable called t. And if we go ahead and use a print string node and just hook up the value of t right into it, then we'll see the value of t and it's increasing. It's basically like a stopwatch. Now we're going to use the value of t. So I'm going to go ahead and delete the print string node, and I'm also going to delete that conversion node. And what I'd like to do is use the sine function. Now if I right click and type in sine, we'll see that Unreal Engine has two versions of the sine function, one that takes radians and one that takes degrees. So Unreal Engine has gone through the trouble of defining the sine function for us in terms of both units of angular measurement. Let's go ahead and choose sine radians. This is the traditional sine function. And as we know, sine requires an angle. In our case, we're going to pass in the time. And we know that sine is a function that returns a value that will go up and down smoothly as the input value increases. So here's what I'd like to do here in the tick function. I'd like to call the function addActorWorldOffset. And addActorWorldOffset requires a delta location. This is a vector. But I'd like to change the z value every frame. Now, in order to change just one component, we can right-click on this input and select Split Struct Pin. And this allows us to change values of this delta location input individually. I'd like to change the z value. So if we plug in the sine straight to z, we can see what happens as we're adding this sinusoidal input to the z. So we know that sine is going to increase and decrease up to +1, back down to -1, over and over, but in a smooth manner. So let's see what this looks like. And there we go. We see that it's going up, and it's going back down, and it's going back up. So we have bobbing up and down behavior, and this is cool, but what if we'd like to control the way this happens? Well, we can easily do that. let's say we think that the sine function is bringing it up too far. Well, we can take the value returned by the sine function and multiply it by using a multiply node. Let's say we want to cut that in half. So let's multiply by 0.5 and instead plug this into delta location z. Now we see that we're not quite going as high. We're going high, but not as high. And we can decrease this even further. Let's multiply by 0.25. And now we see that we're not going nearly as high as we were before. Now, let's say that we think that this is happening too slowly. Well, what we can do is we can take the value input into the sine function and we can multiply it. So we can take this value returned from the setter, which is the value of t, and multiply this. And I'm going to multiply it by 2 and plug that in. Now, if we press play, we're bobbing up and down faster. Now, we can multiply this by, say, 10 to get a really fast up and down motion. And there we see what's going on. We have sinusoidal movement. Okay, great. So this is how we can use the sine function to change our actor's z location. But as this is a C++ course, we want to do this in C++. So I'm going to go ahead and delete these nodes and delete that variable t and compile and save. And we're going to hop back into our Visual Studio project. Now, I think I'm done adding a world offset. I think I'd like to stop moving our actor in the X direction. So what I'm going to do is delete these lines. And I'm going to go ahead and delete these lines here as we're no longer using that movement rate and the rotation rate. I'm still going to keep our macros here so we can still see our actor's location and visualize its rotation by drawing that forward vector. But what I'd like to do is make a variable to keep track of the running time and add delta time to it every frame. So here's what we're going to do. We're going to go to the item.h header file for item, and I'm going to make a private section. So just under the protected section, let's add a private one so we can have a private variable. Now this will be a float, and we're going to call this running time. And we're going to add to this every frame. So back in item.cpp, let's add to running time. And we can say running time plus equals delta time. As you may know, plus equals will take the value of running time and add delta time to it, and then reassign that result back to running time. So this is functionally the same thing as saying running time equals running time plus delta time. But using plus equals is just a shorthand for that. So we're going to say running time plus equals delta time. Now we have running time updating every frame, kind of like a stopwatch. Now I'd like to use the sine function. So here's what I'm going to do. I'm going to make a local float variable, and I'm going to call this delta z, as this will be the change in z that we add to our item. And we're going to use the sine function. Now, the sine function is a static function belonging to a class called fmath. Fmath is a math library that contains tons and tons of mathematical functions, and one of them is sine. And the sine function expects a double value. We can pass in a float if we like, and what we're going to pass in is running time. So our delta z will be the result of this sine function, but we did see that we kind of would like to multiply this by a value to sort of scale how far it goes up and down. That distance that we travel up and down is called the amplitude of the sine wave. We're creating a wave with our sinusoidal motion. And the sine wave has an amplitude. Now, if we multiply this by, say, 0.25f, then we're setting the amplitude to 0.25. And we did notice that we may want to multiply running time by a value to speed up the sine wave. So we can multiply this by 5.f. Now we need to actually add this change to our actor's location. So we can call add actor world offset and pass in an f vector. And the f vector can take in 0 for the x, 0 for the y, and delta z for the z. And now we'll add this value, which is the result of our calculation, using the sine function every single frame. So let's go ahead and save this and go back into the editor, and we'll go ahead and hot reload. Now that we've compiled here, let's go ahead and hit play. And now we're no longer moving in the x direction. We removed those lines of code. We're no longer changing the rotation. All we're doing is adding a local offset in the z location. And sometimes that value returned by the sine function is negative. Sometimes it's positive. That's why we keep going up and down like this. So now that we have a sine function that we're using in tick, we have a couple of values. We have one for the amplitude, and then we have this value that we're scaling our running time by. Now, these are hard-coded, which means we're just adding these values in the code directly. But we can make some member variables for these, just like we made running time a member variable. And that way, we could simply change the values of our member variables rather than going in and hard-coding these. So I'd like to make a float for our amplitude. So let's make a float here called amplitude. And we're using the value of 0.25. We can simply give this the default value of 0.25f. Now we can do it here. This is totally legal. Some people prefer to initialize it right away like this. Or if we wanted to, we could hold off and do it in the constructor, because we have a constructor up here. So we could say amplitude equals 0.25f, and we could do it that way. Now, there's a third way that you may be aware of in C++, and that's to add a colon here right after the parentheses, and then initialize amplitude here. And we could say 0.25f, and we would do it here in parentheses like this. This is another way to initialize. Now, technically, the first way that I showed you, using the assignment operator and assigning this to a value here, is variable initialization. We're actually initializing it as soon as we're declaring the variable. And this method here, which is known as an initializer list, this is also initializing it. We're setting it to a value as soon as it's created. But this method here, setting it to 0.25f in the constructor body, is technically not considered initialization, but rather assignment. The variable starts off uninitialized, assuming that we're not initializing it here or in the header file, and then we're assigning it, which requires one more step in the code. So technically, this method here is slightly less efficient than this method or this method here. Now, we're talking negligible differences in efficiency, so really, it's not going to matter that much. But for those of you who want to do things the absolute most efficient way possible, you're not going to do it this way. You're not going to assign it in the body of the constructor. You're going to do it either this way or this way. Now, throughout this course, I'm going to do it this way. And I leave it up to you to choose which way to initialize your basic variables, such as floats and things. So I'm going to remove this initializer list from the constructor, and we'll have our variable initialized here in the header file. Now, that creates our amplitude. We need another variable that we're going to use to scale our running time right here in the tick function. Now, in trigonometry, we say that the period of our sine wave is equal to 2 pi divided by k, where k is this value. And the period is the amount of time, in this case, that the sine wave requires to go all the way up, all the way down, and back to its starting location. So that's the definition of the period, and this is typically referred to as k, but what we can call this is our time constant. So we're going to call this float time constant, and we're going to initialize it to a value of 5.f. And now here in our tick function, instead of 0.25f, we don't have to hard code this anymore. We can use amplitude instead. And instead of 5.f here, we can use time constant. And then if we ever want to change the behavior of our sine wave, we can go back here and change our amplitude and our time constant. Awesome. So I'm going to go ahead and click Save All, hop back in the editor and hot reload again. And now we can press play and see that we still get the same behavior. Excellent job. All right, that'll wrap this up. I'll see you in the next video.